Hello students. In the previous video, we discussed about the close packed structures. That means how the particles are arranged. That is closely arranged. And we have discussed the different arrangements, how the particles are arranged. Since the particles are considered to be hard sphere, so it will not occupy the whole space, but there will be some space, that is free space will be there. So in whatever way the particles are arranged or packed, there is always some free spaces left, that is in the form of voids. So the packing efficiency is the percentage of how much of total space is occupied by the particles. So let us discuss packing efficiency. Let us first define the packing efficiency. Packing efficiency is the percentage of total space occupied by the particles. That means the particles are closely packed, but still some space will be there. That is free space. So how much of the total space is occupied by the particles, that we need to calculate through a derivation. So recall some points which we have already discussed. That is, in simple cubic unit cell, particles are at the corners. So here the number of particles we have calculated, that is number of atom, is equal to 1. Here the radius and edge length, we have find out the relation, that is R is equal to A by 2. In BCC, particles are not only at the corners but at the center. Here the number of particles is equal to 2. The radius and edge length relation is given here. Similarly, in FCC, the particles are there at the corners, but here the particles are also at the center of each face. So Z is equal to 4, that is number of atoms present in the FCC equal to 4. And the relation between the radius and edge length, that is given here. So by using the knowledge of these, we will find out the packing efficiency for this arrangement. First, let us discuss for simple cubic unit cell. Simple cubic unit cell. Let us find out the packing efficiency in simple cubic unit cell. As we discussed already, there are particles at the corners, but whole together it make only one particle. Therefore, Z is equal to 1. Number of particle is equal to 1. Let A is the edge length of the unit cell. R is the radius of the sphere. R is the radius of the sphere, means here the particles are considered to be hard sphere. Let the radius of the sphere is R. Packing efficiency can be calculated by the formula, that is volume occupied by the spheres per unit cell divided by volume of the unit cell. Since here the particles are spheres, so we need to find out the volume of the sphere. So what is the formula for volume of the sphere? That is 4 by 3 pi r cube. In the previous video, we have derived a relation between the edge length and the radius, that is r is equal to a by 2. Substitute this value in this equation. We'll be getting volume of the sphere is equal to 4 by 3 pi a by 2 whole cube. Here the volume of the cube is A3 because The cube, here the unit cell is a cube. So your volume of unit cell means the volume of the cube. And we already know the formula for volume of cube is A cube. That is length into breadth into height. Since here length, breadth and height are same, altogether we can say A cube. So we got volume of sphere, that is the volume of the occupied by the spheres per unit cell, and volume of the cube, that is the volume of unit cell. Now substitute these two values, that is volume of the sphere and volume of the cube, in this equation. Then when we substitute this, we'll be getting 4 by 3 pi into a by 2 cube divided by a cube. When you solve this one, you'll be getting this value. After substituting pi value, when we do the calculation, we'll be getting this value, that is 0.5233. Approximately it is 0.524. So if you are taking the packing efficiency in the form of percentage, it will be multiplied by 100. So we'll be getting 52.4%. So in the simple cubic unit cell, or we can say SCC, the packing efficiency is equal to 52.4%. Let us find out the packing efficiency in body-centered cubic unit cell, or we can say body-centered cubic arrangement. Here the particles are not only present at the corners but also one at the center, that is body center. So the total number of particles present in this equal to Z is equal to 2. Let A is the edge length, R is the radius of the sphere. Formula of packing efficiency, that is the same, volume occupied by the spheres per unit cell by, or we can say divided by, volume of the unit cell. Volume of the sphere, we know that it is equal to 4 by 3 pi r cube. But r is root 3. R is equal to root 3 by 4 into A. Substitute the value of R in this equation. Then we'll be getting 4 by 3 pi root 3 by 4 A cube, whole cube. But here total number of atom is actually 2. So here there are 2 spheres. So we need to find out the volume of 2 spheres. In the previous one, that is in the simple cubic, only 1, Z is equal to 1. Therefore, there we have calculated volume of 1 sphere. Here 2 spheres are there. So we need to find out the volume of 2 sphere. That is equal to 2 into 4 by 3 pi, and in the place of r we are writing root 3 by 4 into A, that is whole cube. So volume of the unit cell, because the unit cell is a cube, therefore we can say volume of the unit is equal to A cube. Now let us substitute this value in the formula, that is volume of 2 sphere and volume of the unit cell. Substitute in this and we'll be getting, substitute in this, we'll be getting this form. And when we solve this one, after substituting the value of pi, that is 3.14, when we do the calculation, we'll be getting 0.6805. And the terms of percentage, it will be 68.05. So thus What is the packing efficiency in the body-centered cubic arrangement? That is 68.05%. Let us find out the packing efficiency in face-centered cubic unit cell, or we can say cubic close packing, or in CCP arrangement. Here CCP arrangement, or we can say FCC arrangement. Here the particles are not only present at the corners but also at the center of each face. So when we find out the number of particles, we'll be getting Z equal to 4. Let A is the edge length, R is the radius of the sphere. Formula for packing efficiency, it is the same formula which we have discussed in the first and 2 case. So volume of the sphere, that is 4 by 3 pi r cube. Here R is equal to root 2 by 4 into A. Now substitute the value of R in this equation. Since here total 4 particles are there, so we need to find out the volume of 4 spheres. So volume of 4 sphere is equal to 4 into. Why we are multiplying 4 here? Because the number of spheres are 4 here. So volume of one sphere is 4 by 3 pi r cube. Then the volume of 4 sphere will be 4 into 4 by 3 pi r cube. So the value of R is substituted here. So we are getting this equation. And we know that the unit cell is a cube. Therefore, volume of the unit cell means volume of the cube. That is A whole to the power cube. Whole to the power 3. Now when we substitute these values in our formula, that is a packing efficiency formula, these two in this formula, we are getting these two in this, we will be getting 4 into 4 by 3 into pi root 2 by 4 into A cube divided by A3. When we solve this one, after substituting the value of pi, we will be getting 0.7406. In terms of percentage, we can say 74.06%. So let us conclude. Till here we have discussed 3 main type of unit cell. The structures are given. In one of the video we have calculated the number of atoms in these, that is this, this and this. And we have calculated the radius, that is the relation between the radius and the edge length of the unit cell, that is this and this. And in this video we have find out the packing efficiency, that is 52.4% in SCC, in BCC 68%, and in FCC 74%. So from this packing efficiency, it is clear that the close packing, that is HCP or CCP, are equally efficient because it occupies 74% of the available volume. On the other hand, body-centered structure, its efficiency is quite lesser than FCC, that is 68%, while the simple cubic structure has only 52.4% of efficiency. So, thank you everyone.